Hi, I'm Michaela Torbett, Math 241, Section 12, and today's lesson will be on sources and sinks for vector fields. We'll be starting today's lecture defining what it means for a vector A to be a source or a sink for a specific vector field F. So, to begin, we'll let F be a C1 vector field from R3 to R3. And we can let A be a vector in R3. Then we can say that A is a sink for F if the divergence of F at A is less than 0, meaning that the net flow is inward at this specific point in the vector field. Then we can define A as a source for F if the divergence of F at A is greater than 0. This is supposed to be 0, not A. So less than 0, A is a sink for F, and greater than 0, A is a source for F. In this case, this means that the net flow is outward at this specific point. We're now going to look at an example of a C1 vector field G from R3 to R3 such that every point inside of the unit sphere is a sink and every point outside of the unit sphere is a source for G. So we can note from this, well, first we will define A as a vector in R3. So then, based on our unit sphere conditions, we know that the magnitude of A equals 1 if and only if x squared plus y squared plus z squared minus 1 equals 0. Then the magnitude of A is less than 1 if and only if x squared plus y squared plus z squared minus 1 is less than 0. And the magnitude of A is greater than 1 if and only if x squared plus y squared plus z squared minus 1 is greater than 0. So, next we can define our vector field G to be the vector field 1/3 x cubed, 1/3 y cubed, and 1/3 z cubed minus z. So then, computing the divergence, we see that the divergence of G is equal to x squared plus y squared plus z squared minus 1. Now for A to be a source for G, then the divergence of G at A must be greater than 0. And we can see that when A is greater than 1, when the magnitude of A is greater than 1, x squared plus y squared plus z squared minus 1 is greater than 0. And since our divergence of A, or our divergence of G at A is x squared plus y squared plus z squared minus 1, then we know that this is true for all A greater than 1 in R3. This is also similar. The divergence of G at A is less than 0, meaning that it's a sink for all A less than 1 in R3. And lastly, the divergence of G at A equals 0, meaning it's not a source or a sink for all A equal to 1 in R3. Lastly, we're going to answer the question, is it possible for a C1 vector field H from R3 to R3 to have exactly one source? So for this to be true, the divergence of H at A would have to be greater than 0, but only for one A in R3. And the answer is no, because logistically, if you think about this, in R3, a 3D space, there's going to be a range of values that produce an outcome greater than 0 for any vector field. Overall, in today's lecture, we defined what it means for A to be a sink for a vector field F and for A to be a source for that vector field F. And then we looked at a great example in which A was a source for a vector field G everywhere outside of the unit sphere, and it was a sink for G everywhere inside of the unit sphere. And then lastly, we defined that it is not possible for a C1 vector field H from R3 to R3 to have only one source.